Welcome, this is the Chapter 1 review, page 1. The first problem tells us that we've got a function and we want to figure out what g of negative 1 is. Well, I've got g of x plus 3, but I want that to be negative 1. So let's just make x plus 3 equal to negative 1. What's x? Well, subtract 3 from both sides to get negative 4. With that, I'm going to now put negative 4 in for x. I've got g of negative 4 plus 3 equals 2 times negative 4 plus 1. Now negative 4 plus 3 gives me g of negative 1. That's exactly what I wanted to find. 2 times negative 4 is negative 8 plus 1 gets me negative 7. And we're done. So, the second problem. I have j of x, it's this quadratic function, but I don't want to figure out what j of x is, I want to figure out what j of x minus 3 is. So, I'm going to instead for every x put in x minus 3. J of x minus 3 will be equal to not x squared, but x minus 3 squared. Plus 5, not x, but x minus 3. And finally, minus 1. X minus 3 squared is x squared minus 6x plus 9. 5 times x minus 3 plus 5x minus 15. And still minus 1. With that, let's clean this up a little bit. With that, now I can combine terms. X squared's on its own, it's still x squared. Negative 6x and positive 5x, well that'll just get me negative x. 9, negative 15, and negative 1, I believe gets me negative 7. This right here is your answer. X squared minus x minus 7. If I could factor that, I absolutely would, but I don't think I can. Can I? No. Okay. The domain and range of g of x. I notice a couple things here. First off, I'm dealing with a fraction, but I'm also dealing with a fractional exponent, which can also be thought of as a square root. 3x minus 1. So, a couple things that make this function break. When the denominator is 0. So I got to make sure that the denominator is not equal to 0. Otherwise, it'll be undefined. I can't put in an x that makes the denominator equal to 0. Also, what breaks this function? When this is less than 0. If 3x minus 1 is less than 0, I'm taking the square root of a negative number. It gets me an imaginary answer. There's a problem. So, I've got to say 3x minus 1 is going to be greater than 0. It can't be less than 0 because that'll get me the imaginary number, and if it's equal to 0, then the square root is 0 and the denominator is 0, and we've got another problem. So, for the domain, 3x minus 1 has got to be greater than or equal to 0. So, 3x is greater than, oh sorry, not greater than or equal to, strictly greater than 0. So 3x is strictly greater than 1, or x is strictly greater than 1/3. This is my domain. I could write it as x such that x is greater than 1/3. If I want to do it in interval notation, no, sorry, if I want to do it in set notation, if I want to do it in interval notation, I can write 1/3 to infinity. Now, that's the domain. Let's talk about the range. The domain's possible inputs, what can I put in for x? The range is what can I get out? This takes some more difficult thinking. I think that if you wanted to, you could find the inverse of this function and find the domain of that. But let's stick with what we know from chapter 1. Now, we already said that when you take the square root, you've got to take the square root of a positive number. So the denominator here is always going to be positive. If the denominator is always going to be positive, then the fraction is always going to be greater than 0. It can't be 0 because then that's sort of the denominator being 0, which makes it undefined. The numerator definitely can't be 0. So the range, well, it's always going to be a positive number, and it's never going to get quite to 0. The range should be from 0 to infinity. Alternatively, you can say x such that x is greater than 0 if you want to write it in set notation. This has been the first page of the Chapter 1 review. I hope that you find it helpful.